Hello and welcome again. So this is a video for a series wherein we are going to build a real life to-do application, and this is the first part of the series where we are going to build the task service, and we are going to see three important aspects of a real life Spring Boot project. The first aspect is how we actually structure our Spring Boot projects like a pro, like a professional. Second is how we actually design the endpoints and what are the status codes we return from the endpoints. And third is how we actually invoke a database, we retrieve data from the database, we store data from the database, we update data in the database. So these are the three main things that we are going to see in this task service. So let's get started, and this is definitely going to help you to become a pro of Spring Boot if you are a beginner or if you are just starting with Spring Boot. So in order to start with the project, in order to build a microservice in Spring Boot, the task service rather in Spring Boot, please navigate to my GitHub repo, which is github.com/mshomik78 and then Spring Boot projects. And when you are in Spring Boot projects, please go to the branch Todo App part 1, which contains the code for the task service, as I mentioned. And as always, I have absolute detailed instructions written here, so you can clone the repo, then you have to compile, you have to create the package, and then you have to run the service. So now I'm going to show you how we can do that. So I have already downloaded the package. I have already cloned the GitHub repo, and I need to just create a package of that. So I will execute this command to create the package, and let me show you the code structure. The first thing in a Spring Boot project is this project structure. Now, what are the important things in the project structure? You will see that we are having this main packages. The first is the controller, which contains all the REST controller where the external HTTP request lands. So this is the controller layer. So this is the first point of entry in Spring Boot. I will show the class in detail, but let me first show you the directory structure. So this is the controller, and then this is the service layer. So the controller basically calls the service layer. The service layer contains the business logic. And then the DAO layer basically contains database access object. So basically contains the logic to access database. So at this moment, I am actually using an embedded H2 database with Spring Boot for simplicity, but we can actually change the Spring Boot configuration to point to any other database like MySQL, or maybe even an easier, smaller database, or whatever you want to actually connect to. So that was controller, service, and DAO. But apart from that, we also need some other things like the model. So task is the model which is passed all along. So that is basically the value object, and also some exception and exception handler. So this is a custom exception which I am using, and this is an exception helper. If there is any exception which happens, then this exception helper is responsible for actually returning a specific response code to the client. We will see all that in detail. So this is the project structure. This is a standard directory structure of Spring Boot, and I would strongly recommend you to follow the standard directory structure in your professional project. This is actually the best practice from a professional Spring Boot project. Now, second thing is, let us go to the controller layer. So this is the controller layer wherein the HTTP request first lands in, and so you can see that this controller layer's endpoint is API/1. 1 is for the version, so I can have another version running in parallel by the name 2, and then this are the tasks endpoint. As you can see that I have different mapping for the task endpoint, like the post mapping. The post mapping is essentially used to create anything. So the post mapping is used to create a task here. Then the put mapping is used to actually update a task. The get mapping is used to retrieve all the tasks, and this get mapping with this path, with this task ID in the path, is used to retrieve the detail of a specific task. and this delete mapping is used to delete a specific task. So the best practice of naming the REST endpoint is that the REST endpoint name should be noun like tasks, and with the HTTP method name like the post, get, and the delete and the put, we can actually segregate the different actions on the endpoints. So I also have a dedicated video which I will attach over there. So that dedicated video talks about how we should name our REST endpoints, what are the best practices we should do, and what are the things we should avoid. So please also feel free to navigate to that video and understand the best practices in naming the REST endpoints. Now, this is how we actually name the endpoints following the best practices in Spring Boot. So as you can see here, if I scroll up in the controller layer, the service is injected. So this is dependency injection of Spring Boot, and this is a constructor injection, and the constructor is injected because I have used Lombok here, which is also another professional tool like pro-grade tool to actually inject constructor. Otherwise, without Lombok, I had to actually write the constructor. The Lombok has actually generated the constructor, and this is the annotation for Lombok, like required args constructor. With that annotation, Lombok will generate the constructor in the class. Then let us go to the service layer. You will think that from the controller layer I can go to the database layer, but it's always a good practice to have a service layer, because in service layer I can actually write my business logic. Like say for example, when I'm updating the task or when I'm deleting the task, the first thing that I'm checking is if the task actually exists. So if the task does not exist, then I will simply return an error saying that the task does not exist. So this is actually a business logic, very simple business logic though. When I'm creating a task, I'm checking if the user has provided any task description. If not, then I'm setting the description equal to the task name. Then I'm also checking if the user has set any tasks end date. If not, then I'm setting an end date which is from current date to 7th day from the current date. And when I'm retrieving a task detail, of course, I'm checking if the task actually exists. So this is the business logic. So that is why it is always advisable to segregate the controller from the service and also have a separate DAO, because the controller will have only logic related to HTTP, basically receive the HTTP request and then send back the HTTP response. The service will have all the business logic. In fact, in future we will add more business logic in the service. We'll also have validation, and the DAO layer is about querying the database. So if I change my database from H2 to say some other database like MySQL or maybe Postgres or any other database, then only my DAO layer will be impacted. So this is the DAO layer where I have handwritten the queries. So I have used JDBC template. JDBC template is an alternate approach to JPA. So in JDBC template, we have to write the queries, but it also gives a lot of flexibility. Like if you have to do any kind of query performance tuning, you can easily do it using JDBC template, because you can directly update the queries here. So here are the insert, update, select, and the delete queries. Like here is the code for creating the task where it is executing the insert query. Similarly, it is executing the update query here. It is executing the delete query here, and it is also executing the get queries here. So this is the DAO layer, which is the final layer, which finally dispatches the call to the database. And we are using an in-memory database here. So this is the application YAML. We are using an in-memory database just for simplicity. What it means is when I shut down the app, any data which was stored in the database will be lost. So this is just for demonstration purpose, and that's why I chose this, because then we do not need to actually set up another database. It will not have any external dependencies. So these are the three important things. And also let us see the pom.xml. So the pom contains the Spring Boot starter web, which gives us the infrastructure for setting up the controller layer mapping and everything. Then the Lombok, which gives us the infrastructure for generating the constructor, etc., without writing the code of constructor manually. And then the Spring Boot starter JDBC gives us the infrastructure for that JDBC template and the H2 database driver here. So these are the 4 dependencies, and of course the Maven compiler plugin and the Spring Boot Maven plugin. The entire code base is there in my repository. I will also provide the link of my GitHub repo in the description. So you can actually literally download the code, clone the code, and run it without any problem. So that's it about the code walkthrough. Now let us run the project. So I have already compiled the project. I have already created the package of the project following the command here. So you can just follow the command here. What you need to do is you need to have JDK and Maven set up in your local system, and they should be in the path. So the JDK should be 17 or higher than 17. Now I have already run the Maven clean package. Now I will run this command to start the Spring Boot server. So it started the Spring Boot server. So you can see the Hickory pool. So the Hickory pool is basically a connection pool, which is also something Spring Boot gives to us free along with any database connection. So just see that Spring Boot has got so many freebies. That's the main reason that Spring Boot is so popular. Now the Spring Boot project has started at port 8085 because that's the default port, that's not the default port, that's the port which I specified here. You can change the port, you can use the default port, up to you. Now let us execute the command to create tasks, to retrieve tasks, to delete tasks, etc. And all the commands are there in the README. So how I can create the task? Using this command, I should be able to create the task. 1 minute. Okay. So what this command is doing, it's sending a HTTP post request to the endpoint API/1/tasks, and with the JSON this. So this contains some task details like task name, task description, task percentage completed, etc. So let me do one thing. Let me delete the task description, because then with the logic in the service layer, it will populate the task description. It will make the task description to be equal to the task name. So now the task is created. So that is why it has returned HTTP status 201. Remember that we should try to always return HTTP status 201 whenever we are using post, instead of returning HTTP status 200, because HTTP status 201 actually is or has been designed for any creation of resource. So that's why I have actually annotated this with @response status this. So if you annotate it like this, then it will not return the default 200 status, rather it will return this status, which is 201. Now we will try to see if the task has been created by simply executing this command, whether the task has been created. Yes, we can see the task has been created, and the task description has been created is equal to the task name, because I did not specify the task name, and that was a logic which was there in the service layer, and the task end date is 7 days from today's date. So you can also retrieve all. So let me create another task, and maybe like with task name task 2. So another task has been created, and I can try to retrieve that task. So that task is also created. See, the task description is the same as the task name, because again, that was the logic which was specified. And if I do a tasks, so there is also one endpoint out here which lists all the tasks, which is this endpoint, which lists all the tasks. So if I do not specify a task ID here, it will basically get the task name, because I'm not returning everything related to the task. I'm actually returning only the task name. So this is the first endpoint which will be called to retrieve all the tasks, and it will show all the tasks in a list view, assuming that there is a front end which is calling this endpoint. So ideally, there should be a front end written in either React or Vue or in Angular, which calls this endpoint to retrieve the list of tasks, which will show the list of tasks, basically the list of task names. And there would be 3 buttons beside each task name, like edit, delete, 2 buttons, edit and delete beside each task name. And when you click on the edit button, then it will call the other endpoint which will retrieve the task specific to that specific task, which will retrieve the details specific to that task, which is the other endpoint, say for example this one. Now if I try to retrieve the detail of a task which does not exist, for example 20, then it will show me an exception that task ID 20 does not exist. And how it happens? It happens because there is an exception which is thrown here. If you go to the task DAO IMPL, so whenever it tries to retrieve a task which does not exist, then it throws an exception, and the service layer catches this exception. So it throws an empty result data access exception. The service layer catches the exception and it throws an invalid input exception, and this invalid input exception is being caught by this exception helper or exception handler, you can say. So this invalid input exception is being caught here, and then it is returning back to the user an HTTP status not found, which is HTTP status 404. So we have to always, so this is also another best practice of Spring Boot of exception management. Like whenever there is any exception which is happening, we should have a controller advice here, and we should handle that specific exception, and we should return some custom HTTP response code corresponding to that exception. So this is very important because we should not let the consumer of our API grope in the dark about what went wrong. We should be in control, and we should be able to give our consumer very specific response to his request. So that is why whenever the specific task ID is not found, whether you are trying to retrieve a task or update a task or delete a task, you are specifying a task ID which does not exist, then always it returns the invalid input exception, and this controller advice catches that and gives back a response which is HTTP 404, which means the resource does not exist. And how it happens? Because of the code in the service layer, like, so first of all, because of this get task details, which I already showed you, and then you will see that in update task or in delete task, I first called this so that if the task does not exist, it will throw an exception and it will not go to update or to delete. So that's it. I think I have covered all the major, most important pro tips which will help you to become a professional Spring Boot developer. I will recap them once again quickly. First is the package structure is very important. We should segregate the controller, service, and the DAO, because this is single responsibility principle. The controller is responsible for handling the HTTP request response, service is for business logic validation, and DAO is for writing your queries, basically connecting to the specific database. So if you change the database, only the DAO layer will be impacted. If you have to change any validation, if you have to update any business logic, only the service layer will be impacted. If you want to tweak the response code that we want to send to the client, only the controller layer will be impacted. And also the model object, which is the task object, which is used to create the task, which is used to retrieve the task. See, I have created the object, I have created this class using Lombok, so I did not have to write any getter, setter, constructor, etc. So please always use either Lombok or Java record to create this kind of value objects. Never write getter setters by hand. So that was topic number 1. That was the first tip, that we should use this package structure. Second is how we should name the REST endpoints. Like the REST endpoint name should be nouns, and the HTTP verbs, the put and the post, the get and the delete would actually represent the action on the REST endpoints. And the third is how we are querying the database, how we are handling the exceptions. So these are the 3 pro tips. You can always clone my repo and set it up without any problem, provided you have JDK 17 plus and Maven set up in your system. And if you have liked this video, and if you want to continue this series and want other interesting videos, consider liking my video and also subscribing to my channel for other such interesting topics. And thank you for your time and your patience. Sincerely appreciate that.